Section 13.1 here. We are starting off talking about right angle trigonometry. Okay, now if you've already, well, we've all in here taken geometry already. There should have been one word you learned in geometry that for sure came out with you. There's one word. It's not really a word. It's kind of like an acronym. SOHCAHTOA. If you came out of geometry with just one word and one word only, the word you'd probably want to know is SOHCAHTOA, because that leads us into what is right angle trigonometry, and that's what we're going to be using today, is SOHCAHTOA. Who remembers what SOHCAHTOA is? Yeah. A trigonometric ratio compares the lengths of two sides of a right triangle. The values of the ratios depend upon one of the acute angles of the triangle denoted by theta. Okay, that right there, that symbol right there, that is called theta. It is a Greek symbol, theta. Now, we are talking about SOHCAHTOA. Use SOHCAHTOA to remember the relationships between the sides of a right triangle that correspond to the trigonometric ratios sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you will have SOHCAHTOA. Okay, and those are all ratios. Now again, sine is the opposite over hypotenuse. Cosine is equal to the adjacent over hypotenuse. And tangent is the opposite over adjacent. Now, for some reason, sometimes students struggle with, well, yeah, I remember it, but I don't know what opposite means. Okay, so I have theta down here. If you were to look at a side that is directly opposite of theta, what does opposite mean? In another word, what's opposite mean? Just vocabulary terms. What's it mean? Across from, right? So here's theta. What's the side that is across from theta? A. A would be my opposite side of theta. Now, hypotenuse. Let's think about it here. Hypotenuse is always opposite of what angle? The right angle. Does everybody see that? Hypotenuse is always opposite of the right angle. Because if you can recognize those two things by process of elimination, the third side then has to be the adjacent side. Now let's think about it. What does the term adjacent mean? Touching or? What's another word for adjacent? Next to. Very good. So like Maddie is adjacent to Jack. Okay? It is next to. Again, opposite side. You're across from side. Hypotenuse is always the longest side, opposite the right angle. And then adjacent side is the angle that is, or the side that is right next to the angle. Now somebody today goes, well, technically they're both adjacent. Correct. But which one's the hypotenuse? The one that's opposite of the right angle. So recognize that one right away. The one that's opposite of the right angle has to be the hypotenuse. Okay? And if you have to, there's no problem with labeling them, O, H, and A right away. So you recognize those. Alright, so the next one's down here. Use the definitions of each ratio and the corresponding values from the given right triangle to find the values of the trigonometric functions for theta. So here's theta. And again, it might be helpful for you to recognize right away. Here's the opposite side. Hypotenuse is opposite of the right angle. And the adjacent side then is whatever's left over. So opposite, hypotenuse, adjacent. And then I write the ratios in simplest form. Do you all remember recognizing SOHCAHTOA now? Good. John Baylor teach you some good SOHCAHTOA? Maddie's like, no. I hate John Baylor. Alright, so number one here. I want to find the value of sine, cosine, and tangent functions for theta. Okay, so here's theta. First what I want to do is I want to find sine. What is the ratio of sine? Now sine represents opposite over hypotenuse. So what is the ratio for opposite over hypotenuse, John? Sine? Number one? Sine of theta? What? Yeah, opposite over hypotenuse. So I would say 9 over 15, which actually equals 3/5. Nice job. And then I'm going to do cosine. Cosine is the adjacent side over the hypotenuse. What's that going to be, Sean?
Yeah.
12 over 15, which simplifies to? Good work. And last one, opposite over adjacent. Opposite over adjacent is what, Jack? Yeah, for tangent. Number 1?
3 over 4.
Yep, 9 over 12 or 3 over 4. All right, let's go a little bit quicker here. Number 2, sine of theta. Here's theta. What's the sine of theta going to be, Andy?
24 over 26. 12, 13.
Nice job. Cosine of theta is going to be what, Phil? Which equals? Good work. And tangent of theta, Mark?
10 over 24.
Opposite
Yeah.
over adjacent. So what do you get? What's opposite of theta?
24 over 10.
There you go. 24 over 10, which simplifies to?
12 over 5.
Nice job. Number 3, here's theta. I want sine. What's sine of theta going to be, Jarrett?
16 over 34.
Nice job. 16 over 34, which equals 8 over 17. Cosine theta, Maddie? Which equals? Divided by 2. 15 over 17. And tangent of theta, Jack?
For 3, 8 over 15.
Nice job. Because it's 16 over 30, which is 8 over 15. Correct. All right, using that information, take a couple seconds, try 4, 5, and 6 on your own. Find sine, cosine, and tangent of all of these. Number 4, I want the sine of theta. Number 4, what sine of theta is going to be, John? 24 over 25. Nice job. Cosine of theta. Cosine of theta is going to be what, Andy? 7 over 25. Nice job. And tangent of theta. Tangent of theta is going to be what, Jack? Yeah. 24 over 7. Good work. All right, next one's here. Number 5, here's theta. Sine of theta, Sean? 3 over 5. Cosine of theta, Jarrett?
4 over 5.
And tangent of theta, Monahan?
3 over 4.
And the last one, number 6. Sine of theta, Maddie? Sine is? Opposite? And what'd you say?
No, I didn't.
You did cosine.
I did, and then 9 over 41.
So 9 over 41, good work. What's the cosine, Maddie?
40 over
40 over 41. And my tangent function, John? 9 over 40, nice job. Okay, sine, cosine, tangent functions. Feeling pretty good? Good work. Because the next thing I want to talk about is the reciprocals of these. Now, the reciprocals of these aren't used a lot until you get to like more advanced trig. So if you go next year, take is it college algebra and trig? Same pre-calc trig, college algebra trig. Is that what it is? It's Metro College Algebra, right? Okay. So if you take Metro College Algebra trig next year, that's where you get into a lot more depth of this. I'm just gonna give you kind of an introductory of it. Not a big deal. But you get what's called the reciprocals of the sine, cosine, tangent ratios. Now, do you all know what a reciprocal is? Have you heard me ever say refliprical before? Have you ever heard me say refliprical? Now, why do I call it the refliprical? Anybody want to take a guess?
Because you flip it.
Because you're just going to flip it. So what you get here is you get cosecant. The cosecant function is the reciprocal or refliprical of sine. The secant function is the reciprocal or refliprical of cosine. And the cotangent function is the reciprocal or refliprocal of tangent. So if my sine is 3/5, my cosecant is 5/3. If my cosine is 4/5, my secant is 5/4. And if my tangent is 3/4, my cotangent is 4/3. That's all it is. They're just reflipricals. Nothing really crazy special about them. Okay. So let's use that information to help us out here. Number 7. I want to find the values of these 6 trigonometric functions for theta. So the first thing I want to do is I want to find sine of theta. So here's theta. Sine of theta would be what, Andy? 15 over 17. Which means the cosecant then, the refliprocal of that would be what, Andy?
17 over 15.
Nice job. That's what we're doing here. Second part here. Cosine. Cosine of theta is what, Phil? So my secant now, my refliprocal will be what then, Phil? Nice job. And the last one there, tangent. Tangent of theta is what, Mark? Tangent is opposite over adjacent. Which means my cotangent then is 8 over 15. Nice job. Let's try number 8. Here's theta. Okay. What's my sine? Sine of theta is what, Maddie?
It's 36 over
Sine? 15 over what? 39? Which equals, what's that equal? Like 5/13? Which means the cosecant then is I flip that and I get 13 over 5. And then I have the next one, cosine. What is my cosine of that, Jarrett?
Oh, is there cosine? 15 over.
Cosine.
Oh, I G. 36 over 39.
Which equals 12/13. And then what's the secant? The reciprocal of that would be 13 over 12. And the last one, tangent. What's my tangent function, Sean? 15 over 36. And that ends up being, was that 5 over 12? And then I flip that and you get what? 12 over 5. Nice job. Okay, so those are the 6 trig functions. We're going to be focusing more on these 3 a lot in the coming days. Okay. Next part here. Using what we did yesterday. Using what we learned yesterday about the 45, 45, 90s, 30, 60, 90s. Solve for x in these 4 triangles. So you can use trig functions to solve. Or you can just use what you know about 30, 60, 90s, and 45, 45, 90s to solve these. So using what you know about those triangles, solve these 4. So number 9. If the hypotenuse is 12 square root of 2 and it's a 45, 45, 90. Sean, what's x have to be? 12. Nice job. Number 10. 30, 60, 90 triangle. If the long side is 10 square root of 3, what's the short side going to be, Phil? It is 10. Nice job. Number 11. You weren't here yesterday, were you? Huh? I know. I said you weren't here yesterday, were you?
Looks like you're just taking off the square roots.
I mean, if it gives you that way, yeah. Kind of that basic. It's more advanced than that, but what's 45, 45, 90s all about? 45, 45, 90s are all about the square root of 2. 30, 60, 90s are about what? Square root of 3, and then they're also times 2. Okay, just relationships. Number 11 here, though. If the long side's 4 square root of 3, anytime I do 30, 60, 90s, what do I want to find first? I want to find the short side. So the short side is 4, which then means my long side is, or my hypotenuse is 8. Nice job. And then 12. Now 12 should be a gimme here, because what's x have to be? 9. 45, 45, 90, the sides have to be the same there. Okay. Last thing we're going to talk about is using these trig functions with respect to story problems. Okay. A water slide is 26 feet high. The angle between the slide and the water is 33.5 degrees. What is the length of the slide? Anytime you have a story problem, what's the first thing you probably want to do? What is it? Draw a picture, draw a diagram. You can write stuff down, it's fine. But I'd always recommend drawing a diagram. So I have a water slide here. It goes up, it comes down, and I have some cool water down here. Earlier I drew a pretty cool shark. I don't know if I can draw that again. It's a pretty cool shark, right?
Looks like it's dead.
It might be. I don't know. If it's in like a kid's pool here where it's got water slides, it might be dead. There's kind of saltwater sharks. I don't know. So I got the water slide here. Water slide is 26 feet high. The angle between the slide and the water is 33.5 degrees. And I want to find the length of the slide. What trig function am I going to have to use? Of SOHCAHTOA. I want to set up a trig ratio here. What sides am I given and what trig function do I have to use? Anybody? I have the opposite and I have the what? Hypotenuse. That means I want to use sine. So I'm going to take the sine of 33.5 and set it equal to, what's the ratio? What is the opposite? What is the hypotenuse? So sine of 33.5 equals 26 over x. And now you solve for x. Now you can think about it. Some people really struggle seeing it here. So if you wanted to, you can think of it as sine of 33.5 over 1 and do cross products and solve. Some people find it easier to visualize it that way. Otherwise, what I tell them is, when you see x in the denominator, you divide. When x is in the numerator, you would multiply the numbers. Okay? So take a couple seconds here and solve for x. All right, so let's look at 13 here. Andy, what'd you get for an answer?
46.99.
46.99, what we got? Feet. We'd say feet, nice job. And again, what you would do there is you'd take 26 divided by the sine of 33.5. Okay? Yes, sir.
Yeah, I like 47. Is that?
It depends how you round. If you round differently, it's pretty close. 14. A surveyor stands 150 feet from the base of a viaduct. So here's a surveyor. And measures the angle of elevation to be 46.2. Does everybody understand what an angle of elevation is? It's like elevation. If I'm looking here, my angle of elevation is going up. So if he's looking here, or there's his line of sight, his angle of elevation is going there. Okay. And he is 6 feet above the ground. It's 150 feet here. We want to find the height of the viaduct. My angle is 46.2. I want to find the height. What trig function would I have to use here? I would have to use tangent. So I would say the tangent of 46.2 equals x over 150. Again, why is the x over? Because it's opposite over adjacent. Now, if I look at it, x is in the numerator. So what am I going to do with my two values? I would multiply these values now because x is in the numerator. Multiply them. Now, before you get your answer, remember, he is 6 feet above the ground. So what's the last thing you have to do? You have to make sure you add that 6 to your answer. Okay, because it wants the true height, so you have to add that extra 6 there. Okay. And what do you get for that extra 6 feet, or with the extra 6 feet? The height of that viaduct is how many feet? Anybody? Is it 162? 162 point what? Point 4?
0.42.
Feet. Nice job. Okay. Last problem. You can do the same thing. Now you can talk about the angle of depression. Now, the problem with angle of depression is students struggle with is they don't see where it comes in here. I have a helicopter. My helicopters are terrible. It's just like my shark almost.
Solid triangle.
That's a pretty good chopper right there. That's a lot better than the one I drew earlier.
Solid triangle.
Okay. The angle of depression. Angle of depression means the angle as you go down. So this is the angle of depression. Most students think it goes on the inside. It's actually not. It's what goes on the outside. Okay, so I have a right triangle here. Now, what happens is these lines are parallel. So if this angle is 18.8, that means that angle is 18.8. But why?
Could you draw it the other way too?
Do you remember what it's called? Give me one sec, Jared. Alternate interior angles? Do you remember alternate interior angles? And the height here is 1640, and you want to find the horizontal height. Okay, so you'd have to use which function again here? You'd have to use tangent. So I'd say the tangent of 18.8 equals 1640 over x. So as you work this out, x is in the what? X is in the denominator. So does that mean you're going to multiply or divide the numbers now? You're going to divide. So you would take 1640 divided by the tangent of 18.8. And then you end up getting what for an answer? 4,817 feet. Nice job. There's your assignment.